Hello students, this is grade 10 physics class, chapter 12, electricity. In previous video class, we have seen what is electricity. So not exact meaning for electricity. Till now, I didn't start what is the exact meaning for electricity, because before we starting that, we must know some basic things. Then it will be helpful to understand the concept of what is electricity. Is it clear? Yes. So previous video class we have seen what is electricity, then conductor, insulator, then types of charges, then the constituent of 1 coulomb charges. Isn't it? Yes. In this session we will start our next topic. What is that? Next topic. So before we starting our next topic, we must recall what are the things we have seen in previous video class. Isn't it? Yes. So previous video class we have seen what is electricity. Okay, in general meaning for the word electricity, what is that? The flow of electrons are called electricity. Generally we say that is current. The flow of electrons are called electricity. Is it clear? Yes. Then what is conductors? Conductors means nothing but the material which conducts the current, that is called conductor. The material which conducts the current, that is called conductor. Then whereas another one, the opposite to conductor, that is insulator. What is insulator? A material which doesn't conduct the current, that is called, what is that? That is called insulator. Very easy. Isn't it? Yes. Then next question rising here, why conductor conducts the current? Why conductors conduct the current? Because conductors have free electrons. So many free electrons in their outer orbit. Isn't it? Yes. Whereas insulators do not have the free electron as that of conductor. That is the reason why they do not allow the current to pass through them. Which means insulator do not conduct the current. Okay, that is depend on the free electrons, which means valence electrons in their outer orbit, outer cell. Is it clear? Yes. Then after that we have seen the types of charges. What is that? Types of charges. Namely, there are two types of charges. The first one, that is positive charge, and second one, negative charge. Isn't it? Yes. The positive charge possesses, which means electron possesses some energy. Okay, which means that is, what is that? That is charge. Electron possesses some charge, as well as proton also possesses some charges. Okay, what is the charge rates, amounts? 1.6 into 10 to the power of minus 19 coulomb. Okay, this is for both proton as well as electron. So proton and electron possesses a charge amount is 1.6 into 10 to the power of minus 19 coulomb. Minus 19 coulomb. So what is coulomb, sir, here? Coulomb is a SI unit of electric charge. SI unit of electric charge is coulomb. Isn't it? Yes. Coulomb is denoted by the letter capital C. What is that? Capital C. So what is 1 coulomb, sir? See, already we know coulomb is a SI unit of electric charge. Then what is 1 coulomb? How many charges which is constituting in 1 coulomb? That is very big one mark question. Very, very important one mark question. Yes, isn't it? Yes. We can measure as well, which means we can find out how many charges which is constituent of 1 coulomb by the formula of Q equal to NE. What is that? Q equal to NE. Here, what is coulomb? What is Q? Q means nothing but that is electric charge. N, number of electrons. Then E, what is that? The charge of an electron, which means single electron charge. Isn't it? Yes. So finally, if we substitute this all value, finally we can get 1 coulomb, which is equal to 6.25 into 10 to the power of 18 electrons or protons. Okay, how much? 1 coulomb of charge which is equal to 6.25 into 10 to the power of 18 electrons or protons. So that is the reason why I said already in my previous class, coulomb is a packaging of electrons or protons. Okay, which means generally we say packaging of charges, that is coulomb, because 6.25 into 10 to the power of 18 electrons or proton which combine together makes package, that is called coulomb. 1 coulomb. Is it clear? 1 coulomb. So till now we have seen up to this. See, these all are basic, the fundamental concept. Okay, if you don't know this all concepts, you cannot easily understand, you cannot clearly understand the concept of what is electric current. Okay, that is the reason why I am giving more important for that, the all fundamental concept. Is it clear? Yes, we have seen. So what is 1 coulomb? Electric charges, which means what is the electric charge of electron, charge of proton. Then what is that? Current. What is current? Then what makes why the conductors only conduct the current? Then why the insulators do not conduct the current? The all things we have seen in previous video class. Is it clear? Yes. Next, in this session, we are going to start a very important concept, very important topic, that is electric potential. What is that? Electric potential. Okay, yes. So next topic we will start with electric potential. What is that? Electric potential. You might have heard that word potential in somewhere. You might have heard that word potential. Okay, like that boy has potential, the potential to get good marks, to score good marks in board exam. That girl has potential, like that. So potential. So what is potential, sir? What is potential? In general meaning, in general case, the word potential which means showing capacity, like that. What is that? Showing capacity, was capacity, like that. In general case, isn't it? General case, the word potential which means showing capacity or ability. But in electricity lesson, the word potential which means ability to do some work against some external force. What is that? Against some external force. Okay, look at here. In electricity lesson, the word potential which means ability to do some work against external force or external agency. That is called potential. That is called potential. Okay, look at here. Generally the word meaning potential which means showing capacity. But in physics, exactly in electricity lesson, the word potential which means ability to do some work against some external force. What is that? Against some external force or external feed, or otherwise we can say external agency. That is called potential. That is called potential. Is it clear? Okay, for example, look at here. Let's start with an example. Consider an inclined plane. Consider an inclined plane. So this is an inclined plane. You are here with your bicycle. Okay, so you are here. Look at here. First, consider the inclined plane. You are here with your bicycle. You want to go to top of this inclined plane. So this is the top of the inclined plane, and this is bottom of the inclined plane. You want to go to top from bottom. Note this point. You want to go to top of the inclined plane from bottom with this bicycle by pedaling. Is it clear? Yes. Look at here. Naturally, the gravity pulls the all object towards the earth. Am I right? Yes. Gravity pulls the all object downwards, which means towards earth. But you want to go to the top of the inclined plane against the force of gravity. Here, when you're going up, the gravity pulls it down. Gravity pulls it down. Isn't it clear? Yes. Here, what is external force? Gravity is the external force. Am I right? Gravity is the external force because gravitational force opposes your motion. Am I right or wrong? Yes. The gravitational force opposes your motion. Am I right? Along with this inclined plane. Is it clear? Because gravity pulls the all object towards downward direction, but you want to go to upward direction, which means to top like this direction. Like this direction. Isn't it? Yes. But gravity pulls it down. Here you are giving more force. Note this point. You are giving, which means you are pedaling the cycle very high force, with great force, due to which you are come to top. You are come to top with your bicycle by the great force, by pedaling. Is it clear? Even though gravity pulls down, you are applying more force. You are applying more force, due to which you come to this top. Here you have a potential to overcome the external force. Am I right or wrong? Am I right or wrong? You have a potential to overcome this external force. What force? Gravitational force. So here work is done. Am I right or wrong? Yes. Here work is done against some external force. What is external force? Gravity is the external force. You are giving more force, due to which you are overcoming the gravitational force. So you come to top of the inclined plane. Here work is done. Am I right or wrong? Yes, obviously here work is done because you have moved from bottom to top of the inclined plane. So here work is done against the external force, that is gravitational force. So here you have a potential. Am I right or wrong? Yes, you have a potential. So whenever work is done against some external force or external agency, that is called potential. That is called potential. Is it clear? It's very easy. So first consider the inclined plane. You are here with your bicycle. The gravity pulls the all object towards earth. You want to go to the top of the inclined plane. This is the bottom of the inclined plane. That is the top of the inclined plane. So gravity pulls the all object towards earth. Even though gravity pulls downwards, you are applying more force. You are applying more force on the bicycle, which means by pedaling, due to which you come to top of the inclined plane. Is it clear? Yes. Here work is done against the external force, which means here work is done against the gravitational force, due to which you have a potential. You have a potential. Is it clear? Yes. So that is potential in electricity lesson. Is it clear? Another one example. I'll give another one example. Look at here. Again consider bicycle. Another one example. Bicycle is here. You are on the bicycle, isn't it? Yes. This is ground. Look at here. The second example. You are pedaling the bicycle on the road. You are pedaling the bicycle on the road. The heavy wind, which means strong wind. Okay, look at here. You are pedaling the bicycle on the ground. The strong wind which blows, which falls on your body and bicycle, this strong wind opposes your motion. The strong wind opposes your motion. Even though the strong force opposes your motion, you are giving more force, which means you are pedaling the cycle very, very strong, due to which still you are moving on the road. Still you are moving on the road. Here you have a potential to overcome the strong wind. Am I right or wrong? You have a potential. You have a potential to overcome the strong wind. Even though the strong wind opposes your motion, you are pedaling the bicycles with great force, due to which still you are moving on the road. Still you are moving on the road. Here you have a potential to overcome the blowing wind. Here blowing wind is an external force. You are applying more force on the bicycle, due to which you overcoming the external force, which means blowing wind. Here you have a potential. Here you have a potential. So here work is done against the external agency, which means external force. Am I right or wrong? Yes, obviously here work is done because your position is changed from that point, this point to that point. So whenever position of the object changes, we can say work is done. Already you have studied in the 9th standard. So what is work done? So when force acting on a body, due to which if the object displaces from place to place, here work is done. Work is done. So here also work is done against the external force. What is external force here? The strong wind is the external force. So you have a potential here. Obviously you have a potential to overcome the external force. Is it clear? So both are example for potential. Okay, so what is potential, sir? Potential means nothing but ability to do some work. Ability to do some work against some external force or external field, that is called potential. That is called, what is that? Potential. You keep these two examples in your mind, so very easy, because with the help of this concept we are going to see what is electric potential. What is electric potential? Is it clear? Yes. So let's get started. What is electric potential, sir? What is electric potential? So let's get started. What is electric potential, sir? What is electric potential? Yes. Consider a conductor. Consider a conductor. So it's a copper wire, very big copper wire. You just imagine. You just imagine. Okay, so this is a conductor. Okay, it's a conductor, which means copper wire. You consider copper wire. What is this? This is copper wire, isn't it? Yes. Copper wire. Okay, look at here. Next we are going to see what is electric potential. What is electric potential? To understand that, consider a conductor. Consider a conductor. So I have taken copper wire. You just assume, you just imagine that is copper wire. Very big sized copper wire. Okay, yes. So many free electrons are there. Am I right or wrong? So many free electrons will be there in copper conductor. Is it clear? Yes. Now you consider a single charge, either positive charge or electric charge. Okay, you consider positive charge. You may ask me, sir, why, sir? Why? Because flow of electron is called current. Then why you have taken the positive charge here? Okay, that is for example. Okay, you can take either positive charge or negative charge, no problem at all. Okay, yes. Consider a positive charge is here. Okay, so many charges will be there. So many charges will be there in copper wire. But you just consider a single positive charge. Okay, single positive charge. They placed at point A. Placed at point A. Is it clear? Yes, very simple. Consider the conductor, copper wire. So many free electrons will be there. Charge one, a positive charge will be there, negative charge will be there. Isn't it? Yes. You consider a single positive charge. Here you can consider either positive charge or negative charge, no problem at all. Okay, yes. You consider positive charge, single positive charge placed at point A. Placed at point A. Isn't it? Yes. Look at here. So whenever charge is there, whenever the charge is there, it creates electric field around it. Electric field around it like this. It creates electric field around it. What is this? These are electric field. It creates electric field in all directions. All the direction, not only in only one direction, all the direction, it creates electric field. What is this? This is electric field. See, whenever charge particle is there, it creates electric field around it. What is that? Electric field around it in all directions, not in only one direction, all the direction. Is it clear? Yes. Consider another one charge. Consider another one charge, the same charge, which means the same positive charge placed at infinity. Where? At infinity. So here, consider it is infinity. You just imagine, see, there is no way. See, look at here. For this electric potential and potential different topic, you must imagine, you must assume the concept there is no way. Experimentally, we cannot prove that. Experimentally, no one can prove that. You just imagine. Imagination is very important for this electricity lesson. Okay, for example, the light lesson we can prove by experimentally. We can do that. The lens, if we place the object here, where will the image form? We can prove that. But we cannot prove this electric potential and potential difference. Okay, please try to understand the concept. Please try to imagine. Imagination power is very important here. Okay, yes. Look at here. Consider a positive charge, a single positive charge placed at point A in conductor. In a conductor, consider the same, okay, another same positive charge placed at infinity. Where? At infinity. Is it clear? Yes. So look at here. So this already we know. So whenever charge is there, it creates electric field. Okay, it makes an influence. Okay, which means it creates electric field. Is it clear? Yes. This charge influence, which means electric field, will be zero at infinity. Where? At infinity. Look at here. So this charge will create electric field around it. This charge electric field will be zero at infinity. Where? At infinity. Why, sir? Because the distance increases, the electric field decreases, due to which this charge electric field will be zero at infinity. The charge electric field will be zero at infinity. Is it clear? Yes. Consider here. So we have placed another charge, another same positive charge at infinity. Where? At infinity we have placed another same positive charge. Is it clear? Yes. Consider next, I am going to bring this charge placed at infinity to this point. Where? This point. Okay, do you think that is possible? Of course that is possible. Of course that is possible. Is it clear? Look at here. Consider the charge, the same positive charge placed at infinity. Okay, to bring this charge placed at infinity to this point. Okay, what is that point? Consider this is point B. Point B here, we have to spend more energy. We have to spend more energy. Am I right or wrong? Why, sir? Why we have to spend more energy? Look at here, because this is positive charge, that is also positive charge. Isn't it? This is positive charge, that is positive charge. So, like charges always repel each other, already we know very well. Like charges, like a positive or negative always repel each other. Isn't it? Yes. So, there will be force of repulsion between these two charges. Am I right or wrong? There will be force of repulsion between 2 points. What is that? Force of repulsion. Force of repulsion between 2 points. Okay, is that clear? That's very easy. To bring the charge, positive charge placed at infinity to this point B, we have to do some work. Am I right? We have to do some work, which means we have to spend some energy, because here we are going to bring the positive charge placed at infinity to this point against the electric field. Okay, what is that? Against the electric field. So we have to spend more energy. We have to spend more energy. Is it clear? It's a very easy one. Okay, please try to the concept. Okay, for example, consider I have an object. I have an object in my hand. I have an object. What is this? Cloth. Okay. To carry this object from here to there, I have to do some work. Am I right or wrong? I have to do some work, which means I have to spend some energy to carry the things from here to there. here to there. So likewise, to bring the charge, positive charge placed at infinity, from infinity to that point, which means point B, I have to spend some energy. I have to do some energy. See, energy and work both are same. Energy and work both are same. Already we know that. Okay, so whenever work is done, equal amount of energy is consumed. Whenever work is done, equal amount of energy is consumed. So to bring the positive charge placed at infinity to this point, against this, not this point, against this electric field, we have to spend more energy. We have to spend more energy. Am I right or wrong? Yes. Because this charge placed at A, influence will be there up to infinity. So this charge electric field opposes that point, that charge motion, the charge placed at infinity motion. So that is the reason why we have to spend more energy to bring the positive charge placed at infinity to the point B. Point B, because we bring the positive charge placed at infinity to this against this charge electric field. Is it clear? Yes. Now come to this charge, come to here. We brought the charge placed at from infinity to point B. Point B. Here work has done. Am I right or wrong? Yes. Here work has done because we brought the charge from infinity to that point against the electric field of this point placed at A. So work is done. Work is done. Is it clear? It's a very easy. Please try to mind concept. So when the charge was placed at infinity, it has some potential. It has some potential. Okay, so potential's unit is V. Potential is denoted by letter capital V. So when the charge placed at infinity, it has some potential. Okay, consider it has it may be 80. Okay, the potential which is equal to 80. Okay, where when the charge placed at infinity, the charge has potential. For example, the example value is 80. So when we bring the positive charge placed at infinity to point B, here potential will be more. What is that? Potential will be more. Okay, for example, it will be 100. Why, sir? Why here potential will be more? Because note this point, we bring this positive charge placed at infinity to this point B. This point B is closer to the point A. Am I right or wrong? The point B is placed closer to the point A. So to bring the charge placed at infinity to this point B, we have to spend more energy because we bring the charge against, not this point, against this electric field, due to which at the point B the charge potential will be more compared than infinity. What is that? Compared than infinity. Am I right or wrong? Very easy concept. Please try to understand the concept. Okay, so here at point B, the charge influence, okay, which means the charge potential will be more. So which means at point B, the charge potential will be high. So it is considered as high potential. At infinity, the charge potential will be less compared than the point B. So at the infinity is considered as low potential area. Low potential. Is it clear? It's very easy. So what is the conclusion, sir, here? What is the conclusion? So the amount of, on this point, so the amount of work is done to bring a unit of positive charge from infinity to that point, any particular point, that is called electric potential. It's a very easy. That is called electric potential. Okay, note this point. What is that? The amount of work is done. How much amount work is done here? The amount of work is done to bring unit positive charge from infinity to that point. That point means nothing but any particular point. Any particular point is called electric potential. Electric potential. Okay, here look at here. Here we brought a single point. Okay, here we brought only a single point placed at infinity. Suppose if we brought, note this point, if we bring a coulomb of charge, what is that? A coulomb of charge from infinity to that point, that is electric potential. That is electric potential. So very easy. Is it clear? That is electric potential. I will write the definition. You look at here. The amount of work is done to bring a unit of positive charge from infinity to particular point. That is called electric potential. That is called electric potential. Very easy one. Please try to the concept. Okay, I will explain Tamil later. I will explain. I explain first in English. Again, I will explain in Tamil. Okay, yes. Look at here. Next, we will see electric potential. Electric potential. So consider the conductor, the copper wire. For my convenience, I have taken copper wire because copper is very good conductor. Very good conductor. Okay, consider that test charge. Okay, which means the charge, a single charge placed at point A, that is positive charge. Here we can take either positive charge or negative charge, no problem at all. Okay, so I have taken positive charge. Is it clear? Yes. So consider the positive charge placed at point A in conductor. Consider another one positive charge, same positive charge placed at infinity. Where? At infinity. Is it clear? Yes. So whenever charge is there, it creates electric field around it. That is electric charge. So it creates electric field. For example, take one magnet. Take one magnet and take one's magnetic material. If you bring the magnet very closer to the magnetic field, what will happen? The magnet will attract the magnetic material even though there is some distance between them, between each other. If you bring the magnet very closer to the magnetic material, the magnet will will attract the magnetic material towards it. Okay, why? Because the magnet creates magnetic field around it. Likewise, note this point. Likewise, the electric field also creates, which means the electric charge also create electric field around it. The electric charge also create electric field around it. Is it clear? Yes. This electric field will be zero at infinity. Okay, this positive charge electric field will be zero at infinity because as the distance increases, the electric field intensity decreases. Finally, it becomes zero at infinity. At infinity. Is it clear? Yes. Consider the another same positive charge placed at infinity. Same positive charge placed at infinity. So this charge influence, which means the charge placed at point A influence will be there up to infinity. Is it clear? So this charge electric field will be here, and will be zero at infinity. Is it clear? Yes. So this is positive charge, that is also positive charge. So like charges always repel each other. Am I right or wrong? Like charges always repel each other. So there will be force of repulsion between each other. Okay, yes. So consider this charge placed at infinity. The charge placed at infinity, isn't it? Yes. To bring, note this point, to bring this charge placed at infinity to that point. That point, what is that point? Any particular point, we have to spend more energy. Because, which means we have to do some work against this force of repulsion, or otherwise we can say electric field. Is it clear? Yes. Because this charge influence does not allow the charge come to closer because there is repulsive force. Okay, yes. To overcome that electric field, we have to spend more energy. We have to spend more energy. Is it clear? Yes. So if we bring the charge placed at infinity to that point, we have to spend more energy. So suppose if you brought the charge from infinity to this point, here work is done. Am I right or wrong? Work is done, because whenever the object position changes from place to place, work is done in physics. In physics, work is done. So here also work is done. So at infinity, the charge has some potential, that is low potential. When we bring this charge placed infinity to the point A, which means closer to this point, here the potential will be more, because here energy level of the charge will be more. So this is considered as high potential. So there is a potential difference between the two positions. Am I right? There is a potential difference between the two positions. Is that clear? Yes. So here the amount of work is done. Know this point. So the amount of work is done to bring the unit of positive charge from infinity to any particular place, that is called electric potential. So here unit positive charge, which means nothing but a coulomb of positive charge. What is that? Coulomb of positive charge. What is a coulomb? 1 coulomb, that is equal to 6.25 into 10th power of 18 electrons or protons. 18 electrons or protons, that is equal to 1 coulomb. Okay, so here how much amount of work is done? Note this point. How much amount of work is done to bring 1 coulomb of positive charge from infinity to that point, any particular point? That is called electric potential. That is called electric potential. Is it clear? It's very easy. Electric potential is denoted by letter capital V. Okay, because electric potential and potential difference unit is volt. That is the reason why it is mentioned by V. Is it clear? Yes. So look at here, come to here. So electric potential. So electric potential, which is equal to the amount of work is done, because here work is done by applying force, applying energy. So electric potential, which is equal to work done divided by charge, amount of charge moved, amount of charges moved, or quantity of charges moved, quantity of charges moved, quantity of charges moved. So this is a formula. That is a formula. Okay, look at here. Electric potential, which is equal to work done. Here work is done. Here work is done. So work done divided by amount of charge is moved. Okay, it can be so 1 coulomb, 2 coulomb, so whatever it is. How much amount of charge is moved from infinity to that point? That ratio is called electric potential. Okay, so this is for mathematical concept. That is for theoretical concept. Okay, mathematically we need this formula. Theoretically we need this expression. Okay, yes, that's all. Khatam, very easy one. So generally, so finally, what is the conclusion, sir? What is the conclusion, sir? Electric potential means nothing but the amount of work is done. Note this point. The amount of work is done to bring a unit of positive charge, which means to bring a 1 coulomb of positive charge or negative charge from infinity to any other particular point, is called electric potential. Is called electric potential. So mathematically, electric potential is equal to work done divided by the quantity of charge moved, which means the amount of charge moved. That's all. Very easy one. Very easy. Purida liya. Yes. So I explain Tamil because very important, the basic concept. Okay, yes. I'll explain Tamil. Next என்ன எலக்ட்ரிக் பொட்டன்ஷியல்லாம் பார்க்க போகிறோம். எலக்ட்ரிக் பொட்டன்ஷியல் ஒன்றும் இல்லை, ஒரு கண்டக்டர் எடுத்துக்கோ. கண்டக்டரில் நிறைய ஃப்ரீ எலக்ட்ரான்ஸ் இருக்கும், ஓகேவா? ஒரே ஒரு சார்ஜ் மட்டும் கன்சிடர் பண்ணிக்கோ. பாசிட்டிவ் சார்ஜ் இங்கே இருக்குது, பிளேஸ் ஏல இருக்குது. ஏன் சார் பாசிட்டிவ் சார்ஜ் அப்படின்னா, இந்த இடத்துல நம்ம பாசிட்டிவ் சார்ஜையும் எடுத்துக்கலாம், நெகட்டிவ் சார்ஜையும் எடுத்துக்கலாம், நோ ப்ராப்ளம். ஓகேவா? ஜஸ்ட் ஒரு கான்செப்ட்டுக்காக என்ன பண்ணுறோம், நம்ம பாசிட்டிவ் சார்ஜ் எடுத்துக்கிறோம். ஈவன் நம்ம டெக்ஸ்ட் புக்லேயே என்ன கொடுத்துருப்பான், பாசிட்டிவ் சார்ஜ் தான் கொடுத்துருப்பான். ஓகேவா? எஸ். ஒரு பாசிட்டிவ் சார்ஜ் எடுத்துக்கோ. அந்த பாசிட்டிவ் சார்ஜ் அந்த கண்டக்டரில் ஏங்கிற ஒரு பிளேஸில் இருக்குது. ஓகேவா? எஸ். இந்த சார்ஜ் இருந்தாவே அதை சுற்றி என்ன இருக்கும் அப்படின்னா எலக்ட்ரிக் ஃபீல்டை கிரியேட் பண்ணும். பிகாஸ் தட் இஸ் எலக்ட்ரிக் சார்ஜ். அதை சுற்றி என்ன பண்ணும், எலக்ட்ரிக் ஃபீல்டை க்ரியேட் பண்ணும். இந்த சார்ஜோட எலக்ட்ரிக் ஃபீல்டு எங்கே ஜீரோவாக இருக்குன்னா இன்ஃபினிட்டியில் ஜீரோவாக இருக்கும். ஓகே, பிகாஸ் டிஸ்டன்ஸ் இன்க்ரீஸ் ஆக ஆக இந்த சார்ஜோடைய எலக்ட்ரிக் ஃபீல்டு டிக்ரீஸ் ஆகிட்டு ஃபைனலாக இன்ஃபினிட்டியில் போய் ஃபுல்லாகவே ஜீரோ ஆயிரும். ஆமாவா? எஸ். இன்னொரு பாசிட்டிவ் சார்ஜை கன்சிடர் பண்ணிக்கோ. அந்த சார்ஜ் எங்கே இருக்குது அப்படின்னா இன்ஃபினிட்டியில் நான் வச்சுருக்கேன். ஓகேவா? இதுவும் பாசிட்டிவ் சார்ஜ் தான், இதுவும் பாசிட்டிவ் சார்ஜ் தான். அந்த பாசிட்டிவ் சார்ஜை நான் எங்கே வச்சுருக்கேன்? இன்ஃபினிட்டியில் வச்சுருக்கேன். ஓகேவா? எஸ். ஸோ இந்த இன்ஃபினிட்டியில் இருக்கக்கூடிய சார்ஜை நான் என்ன பண்ண போகிறேன்னா இந்த சார்ஜுக்கு பக்கமாக கொண்டு வர போகிறேன். ஓகேவா? இன்ஃபினிட்டியில் இருக்கக்கூடிய சார்ஜை, பாசிட்டிவ் சார்ஜை நான் இந்த சார்ஜுக்கு பக்கத்தில் ஏதோ ஒரு பாயிண்ட்டுக்கு நான் கொண்டு வரணும்னா நான் என்ன பண்ணணும்? நான் அந்த இடத்துல ஒர்க் பண்ணணும். ஆமாவா இல்லையா? அந்த இடத்துல ஒர்க் பண்ணால் மட்டும்தான் நான் கொண்டு வர முடியும். ஓகேவா? என்ன சார் ஒர்க் பண்ணணும்? ஏன் ஒர்க் பண்ணணும் அப்படின்னா, ஸோ இந்த பாசிட்டிவ் சார்ஜ் எங்கே வச்சுருக்கோம்? இந்த பாயிண்ட் ஏல வச்சுருக்கக்கூடிய பாசிட்டிவ் சார்ஜோடைய எலக்ட்ரிக் ஃபீல்டு ஃபுல்லாகவே இருக்கும், எல்லாமே இருக்கும், எல்லா இடத்துலையுமே இருக்கும். ஓகேவா? ஸோ இதுவும் பாசிட்டிவ் சார்ஜ், அதுவும் பாசிட்டிவ் சார்ஜ் என்ன பண்ணும்? ரெண்டுமே ரிப்பல் பண்ணும். ஸோ அந்த ரிப்பல்ஷனையும் தாண்டி, அந்த ரிப்பல்ஷனையும் ஓவர் கம் பண்ணி நம்ம என்ன பண்ணணும்? இன்ஃபினிட்டியில் இருக்கக்கூடிய சார்ஜை நம்ம ஏதோ ஒரு பர்டிகுலர் பாயிண்ட்டுக்கு கொண்டு வரணும். அப்படின்னா நம்ம என்ன பண்ணணும்? நம்ம அதிகமான எனர்ஜி கொடுக்கணும். ஆமாவா இல்லையா? அதிகமான எனர்ஜி கொடுத்தா மட்டும்தான் இன்ஃபினிட்டில் இருந்து அந்த சார்ஜை நம்ம அந்த பிளேஸுக்கு கொண்டு வர முடியும். ஸோ நம்ம எவ்வளோ ஒர்க் பண்ணி எவ்வளோ எனர்ஜி கொடுத்து இந்த இன்ஃபினிட்டிலேருந்து சார்ஜை இந்த பர்டிகுலர் பாயிண்ட்டுக்கு கொண்டு வரோமோ அதுதான் எலக்ட்ரிக் பொட்டென்ஷியல். புரியுதா? எஸ். ஸோ இன்ஃபினிட்டியில் இருக்கும்போது இந்த சார்ஜுக்கு ஒரு பொட்டென்ஷியல் இருக்கும். அது வந்து கம்மியாக இருக்கும். பக்கத்தில் வர என்ன ஆகும் அப்படின்னா இந்த சார்ஜ் வந்து அப்போஸ் பண்ணுமா, என் பக்கத்தில் வராத நீ போன்னு அப்போஸ் பண்ணும். ஸோ அதையும் தாண்டி நம்ம இந்த பாயிண்ட் பிக்கு கொண்டு வந்தோம்னா என்ன ஆகும்? இங்கே இந்த சார்ஜோடைய இன்ஃபினிட்டிலேருந்து வரக்கூடிய சார்ஜோடைய பொட்டென்ஷியல் அட் பாயிண்ட் பியில் அதிகமாக இருக்கும். ஸோ பாயிண்ட் பி வந்து கன்சிடர்ட் அஸ் என்னவாக இருக்குன்னா ஹை பொட்டென்ஷியலாக இருக்குது. பாயிண்ட் ஏ விச் மீன்ஸ் இன்ஃபினிட்டி வந்து லோ பொட்டென்ஷியலாக இருக்கும். ஓகேவா? புரியுதா? இது சிங்கிள் சார்ஜ் முடியும். சப்போஸ் 1 கூலும் சார்ஜை, நோட் திஸ் பாயிண்ட், 1 கூலும் பாசிட்டிவ் சார்ஜோ இல்லை நெகட்டிவ் சார்ஜோ இன்ஃபினிட்டியில் இருந்து ஒரு பர்டிகுலர் பாயிண்ட்டுக்கு கொண்டு வந்தோம் அப்படின்னா அதுதான் எலக்ட்ரிக் பொட்டென்ஷியல். வெரி ஈஸி. ஓகேவா? ஸோ நமக்கு ஒர்க் பண்ணால் மட்டும்தான் இந்த சார்ஜை வந்து இன்ஃபினிட்டிலேருந்து கொண்டு வர முடியும். எவ்வளோ ஒர்க் பண்ணியிருக்கிறோம்? எவ்வளோ சார்ஜை கொண்டு வரதுக்கு நம்ம எவ்வளோ ஒர்க் பண்ணியிருக்கோம் அதுதான் எலக்ட்ரிக் பொட்டென்ஷியல். தட் இஸ் கால்ட் எலக்ட்ரிக் பொட்டென்ஷியல். புரியுதா? ரொம்ப ஈஸி, நீ குழப்பவே கூடாது. இதை வந்து நம்ம அசியூம் பண்ணி தான் ஆகணும், வேறு வழியே இல்லை. ஓகேவா? நம்ம இதை இமேஜின் பண்ணி தான் ஆகணும், வேறு வழியே இல்லை. நம்ம எக்ஸ்பெரிமெண்ட்லாம் பண்ணவே முடியாது. ஓகேவா? எஸ். ஸோ electric potential which is equal to work done divided by quantity of charge moved. Okay va? Yes, look at it, that's all. So the amount of work is done to bring a unit of positive charge or negative charge from infinity to particular point is called electric potential. Okay, yes, that's all. Katham. So next we will see potential difference. What is that, sir? Potential difference. See, this electric potential and potential difference both are not exactly same, approximately same. There will be few changes, few dissimilarities, that's all. Okay, yes. Okay, so look at here. Next we will see what is that? Potential difference. Next, potential difference. Okay, just now we have seen electric potential. In electric potential, we brought the charge placed from infinity to particular point, but in potential difference we are going to bring the charges from one known point to another known point. Okay, which means from one point to another point. Okay, look at here. So what is the word meaning difference, sir? What is the word meaning difference? Difference means nothing but there will be two things. There will be two things, which means some dissimilarities between two things, that is difference. That is difference. Am I right or wrong? Yes. So here potential difference means nothing but the potential between 2 points. What is that? Potential between 2 points. That is called potential difference. That is called potential difference. What potentials are? The electric potential difference between two charges. Two charges is called electric potential difference, or otherwise we can say potential difference. Potential difference. Is it clear? Yes. See, this potential difference is also known as voltage. Note this point, very important one. The potential difference is also known as voltage. Generally we say that voltage is a 2 volt battery, 5 volt battery, 6 volt battery, like that. That is potential difference. That is potential difference. So the potential difference is also known as voltage and EMF and so many things. Voltage and EMF. Okay, yes, simply we say that even potential also. Sometimes that is referred by potential also. Potential also. Okay, it's all are same meaning. You don't get confusion. So the potential difference is also known as voltage and EMF, even potential, simply potential also. Is it clear? Yes. Next we will see what is potential difference, sir. What is potential difference? Okay, yes. Again consider the conductor. Again you consider a conductor like a copper wire. Consider what is this? Is conductor. Copper wire. Okay, consider conductor, copper wire. Copper is one of the very good conductor of electricity. Okay, yes. So in copper wire, so many charged particles are there. So electrons are there, protons are there, so many things are there, isn't it? Yes. You consider same positive charge. Consider the same positive charge. Same positive. Here you can take either positive charge or negative charge, no problem at all. You don't get confusion. So why, sir? Because flow of electrons is called current, sir. But why here you have taken positive charge? Sir? See, for example, I have taken, no problem at all. Okay, wow. Yes. Look at here. Consider the positive charge placed at point A. Placed at point A. Okay, wow. Consider positive charge placed at point A. So whenever charge is there, it creates electric field around it. Am I right or wrong? Yes. It creates electric field around it like this. All direction. It creates electric field all the direction. What is it? This is electric field. Okay. Yes. Next we consider another one charge. Another one charge is placed here. Other than infinity. Note this point. In first condition, which means in electric potential, the another charge, second charge is placed at infinity. But in potential difference, this another charge is placed other than infinity. Okay, other than infinity. It can be so closer to this point or some distance from this point. Okay, yes, that is some known distance, but other than infinity, not in infinity. Okay, in potential difference, the second charge is placed not in infinity, other than infinity. Is it clear? Other than infinity, like here. Consider this is point B. Point B here. Point B, isn't it? Yes. Look at here. Consider the copper wire. So then consider the positive test charge of positive. Okay, so this one placed at point A, this charge creates electric field around it. So consider the another one same positive charge placed at point B. Okay, see here, not in infinity. Note this point, not in infinity. Some distances from the point A. Is it clear? Yes. Note this point. So this is positive charge, that is positive charge. See, both like charges repel each other. both like charges repel each other. So there will be force of attraction between the two charges. There will be force of attraction between two charges, isn't it? Yes. So come to this point. Here this second positive charge placed at point B. This charge has some potential now. Am I right? Yes, this charge has some potential here. So potential is denoted by letter V, capital V. Potential is denoted by letter capital V. So the charge placed at point B has some potential. Consider, so it is 50. It is 50. Is it clear? Yes. Look at here. Next, I'm going to bring this charge placed at point B to this point, where point C here. Point C here. Okay, note this point. Consider the second charge. This point C here. Consider the second positive charge placed at point B. Okay, yes, I'm going to bring this positive charge placed from point B to point C here. Point C here. Look at here. To bring, note this point. To bring this charge placed at point B to point C, we have to do some work. Am I right or wrong? We have to do some work, which means we have to spend some energy, because we bring the charge placed at point B to point C against the force of this electric field of this charge. Am I right or wrong? To overcome that, we have to spend more energy at the point C. Am I right or wrong? Yes. So if we bring, look at here, if we bring the charge placed at point B to point C, we have to spend more energy. Okay, we have to spend more energy. So consider you brought the charge placed from point B to point C. Point C. What about the potential at the point C? Here potential will be more. Am I right or wrong? Potential will be more. Here the potential may be 80. Why, sir? Why? Because here we bring the charge placed at point B to point C against this electric field, this charge electric field, due to which we have to spend more work, which means we have to spend more energy. So at point C, that charge potential will be more. Is it clear? Yes. Here, what is the potential difference, sir? What is the potential difference? We always minus the potential difference from high potential to low potential. What is that? High potential to low potential. Here, which is high potential, which is low potential? Yes. At point C, the charge has high potential. At point B, the charge has low potential. So what is the potential difference? 80 minus 50, which is equal to 30. So how much work is done? 30 joule work is done here. 30 joule work is done. Am I right or wrong? Because work unit is joule. So here the potential difference between the two charges, that is 30. So 30 joule work is done. That's all. Okay. Here what is the potential difference? Potential difference 30. Potential difference 30. Is it clear? Yes. So what is the conclusion, sir, here? What is the conclusion? Note this point. The amount of work is done. Note this point, very easy one. The amount of work is done to bring a unit of positive charge from one point to another point. Note this point. One point to another point is called potential difference. One point to another point. But in electric potential, we brought the charge, positive charge, from infinity to that point. Am I right? Infinity to particular point. But here in potential difference, we bring the unit of positive charge from one point to another point. Know this point? One known point to another known point. That is called potential difference. Potential difference. Okay, I'll write this definition. Look at here. The amount of work is done to bring a unit of positive charge or negative charge, unit of positive charge from one point to another point, from one point to another point. Another point is called potential. It's potential difference, that's all. This is the definition. The amount of work is done. The amount of work is done to bring a unit of positive charge from one point to another point is called potential difference. What is that? Potential difference. Is it clear? Yes. Look at here. Here at point C, that charge has high potential. At point B, that charge has low potential. Why? Because point C is placed very closer to this point. Okay, which this charge, where the point C is placed very closer to the point A charge, due to which there will be high potential, which means we have to spend more energy at the point C, due to which there is high potential. So the point C is considered as high potential. The point C is considered as high potential. Then point B is considered as low potential. Low potential, obviously. Yes. Low potential. We always, note this point, we always minus from high potential to low potential. I am high potential to low potential. Here, which is high potential? Which is high potential? This is considered as, this is VC and this is VB. Okay, look at here. This is VC, this is VB. V means what is that? Potential at point B. So VB. So here, B means what is the potential at point C? So VC. Okay, so we always minus from high potential to low potential. Yes, so VC minus VB, which is equal to what is that? Which is equal to amount of work is done divided by amount of charge is moved. Yes, so amount of work, which means work done divided by quantity of charge moved. Quantity of charge moved. Charge moved. So this is a formula for potential difference. The formula for potential difference. Am I right or wrong? Yes. Here, what is the potential difference? So at point C, the potential is 80. It is considered as high potential because the point C is placed very closer to the point A. At point B has low potential because that point B is placed far away compared than point C from the point A, so that is considered as low potential. So high potential 80, low potential 50. So high potential minus low potential is equal to 30. The potential difference how much? The potential difference here 30. Potential difference 30. Okay, yes. So potential difference, which is equal to work done divided by quantity of charge moved. Suppose this is for a single charge. Suppose it is for a single charge. Suppose if we bring, now this point, if we bring 1 coulomb or 2 coulomb or 3 coulomb of charge from one point to another point, how much energy we have to spend? That difference is called potential difference. That difference is called potential difference. Okay, this is for a single charge. Suppose if we bring 1 coulomb charge, or 2 coulomb charge, 3 coulomb charge, okay, from one point to another point, how much work is done? That ratio is called potential difference. That ratio is called potential difference. Is it clear? It's very easy. So look at here, potential difference. So potential difference, which is equal to work done divided by charge. What is that? Work done divided by charge. That is potential difference. Note this formula, very easy one. Note this formula, very, very easy one. Okay, yes. Look at here. So potential difference is equal to work done divided by what is that? Charge. Okay, yes. So SI unit of potential difference. The SI unit of potential difference is volt. What is that? Volt. SI unit of this potential difference is volt. What is that? Volt. The after named Alessandro Volta. Alessandro Volta he was a scientist who found that the potential difference between the two charged particle. Okay, for honor of him, that for SI unit of potential difference is known as volt after named Alessandro Volta. What is that? Who's that person? Alessandro Volta. That name has given in your class textbook. You refer that. Okay, yes. So the SI unit of potential difference is volt. What is the SI unit of charge? Electric charge, that is coulomb. Likewise, the SI unit of this potential difference is volt. What is that? Volt is denoted by the letter capital V. Capital V. Is it clear? What is it? Capital V. Is it clear? Very easy one. So I need some space. Okay, so I explained that. Before rubbing that, I'll explain Tamil. Okay, very easy one. Okay, yes. Electric potential என்ன பார்த்தோம்? எலக்ட்ரிக் பொட்டன்ஷியல்னா ஒரு சார்ஜை நம்ம இன்ஃபினிட்டியில் இருந்து என்ன பண்ணோம், ஒரு பர்டிகுலர் பிளேஸுக்கு கொண்டு வந்தோம். அப்படி கொண்டு வரும்போது நம்ம ஒரு ஒர்க் பண்ணியிருக்கோம் அந்த இடத்துல. ஓகேவா? எஸ், அதை விட்டுரு. இப்போ பொட்டன்ஷியல் டிஃப்ரென்ஸ்னால் என்னென்னு பார்ப்போம். டிஃப்ரென்ஸ்னாவே என்ன? டிஃப்ரென்ஸ்னாவே ஒரு ரெண்டு திங்ஸுக்கு இடையில ஏதோ சம்திங் டிஃப்ரென்ஸ் இருக்குது. ரெண்டு திங்ஸுக்கு இடையில டிஃப்ரென்ஸ் இருக்குது. ஆமாவா? எஸ். இதே எங்கள் எலக்ட்ரிக் பொட்டன்ஷியல் டிஃப்ரென்ஸ் அப்படின்னா என்ன அப்படின்னா, ரெண்டு சார்ஜ்டு பார்ட்டிக்கிள், ரெண்டு சார்ஜுக்கு இடையில இருக்கக்கூடிய டிஃப்ரென்ஸ் தான் என்ன சொல்கிறோம்? பொட்டன்ஷியல் டிஃப்ரென்ஸ்னு சொல்கிறோம். ஓகேவா? எஸ். கன்சிடர் பண்ணிக்கோ, ஒரு கண்டக்டரை கன்சிடர் பண்ணிக்கோ. நிறைய பார்ட்டிகல்ஸ் இருக்கும். ஒரே ஒரு பாசிட்டிவ் சார்ஜை கன்சிடர் பண்ணிக்கோ. இங்கே இருக்குது. அந்த பாசிட்டிவ் சார்ஜ் எங்கே வச்சுருக்கோம்னா பாயிண்ட் ஏங்கிற இடத்துல வச்சுருக்கிறோம். இந்த பாசிட்டிவ் சார்ஜ் என்ன பண்ணும்? இதை சுற்றி எலக்ட்ரிக் ஃபீல்டை கிரியேட் பண்ணுமா? எஸ். இந்த பாசிட்டிவ் சார்ஜ் வந்து அதை சுற்றி எலக்ட்ரிக் ஃபீல்டை கிரியேட் பண்ணும். ஓகேவா? எஸ். இன்னொரு பாசிட்டிவ் சார்ஜை கன்சிடர் பண்ணிக்கோ. இன்னொரு பாசிட்டிவ் சார்ஜ் எங்கே இருக்குன்னா, இந்த பாசிட்டிவ் சார்ஜுக்கு கொஞ்சம் தூரத்தில் இருக்குது. ஓகேவா? ஒரு 1 மீட்டரோ 2 மீட்டரோ ஏதோ தூரத்தில் இருக்குது. பட் அதர் தென் இன்ஃபினிட்டி. பட் இன்ஃபினிட்டியில் கிடையாது. இன்ஃபினிட்டிக்கு முன்னாடி எங்கேயோ ஒரு பாயிண்டில் இருக்குன்னு வச்சுக்கோ. கன்சிடர் தட் இஸ் பாயிண்ட் பின்னு வச்சுக்கோ. ஸோ இந்த பாயிண்ட் பியில் இருக்கும்போது இந்த சார்ஜுக்கு ஒரு பொட்டன்ஷியல் இருக்குமா? கண்டிப்பாக இருக்கும். இந்த சார்ஜுக்கு கண்டிப்பாக ஒரு பொட்டன்ஷியல் இருக்கும். பிகாஸ் ஏன்னா இந்த சார்ஜோடைய இன்ஃப்ளூயன்ஸ் விச் மீன்ஸ் எலக்ட்ரிக் ஃபீல்ட் இன்ஃபினிட்டியில் தான் ஜீரோ ஆகும். எங்கே ஜீரோ ஆகும்? இன்ஃபினிட்டி தான் ஜீரோ ஆகும். ஸோ அதுக்கு முன்னாடி ஏதோ ஒரு இன்னொரு சார்ஜ் சேம் சார்ஜ் அந்த இடத்துல பிளேஸ் பண்ணினா என்ன இருக்கும்? அதோட இன்ஃப்ளூயன்ஸ் எங்கேயும் இருக்கும். ஸோ இதுக்கு பொட்டன்ஷியல் இருக்கும். இந்த சார்ஜுக்கு ஒரு பொட்டன்ஷியல் இருக்குமா? எஸ். ஸோ இந்த பியில் இருக்கக்கூடிய சார்ஜை என்ன பண்ணணும்னா சிக்கு கொண்டு வரணும்னா என்ன பண்ணணும்? நம்ம ஒரு ஒர்க் பண்ணணும். அந்த இடத்துல நம்ம வந்து ஒரு ஒர்க் பண்ண வந்து எனர்ஜி கொடுத்து இந்த சார்ஜஸ் பியில் இருக்கக்கூடிய சார்ஜஸ் சிக்கு கொண்டு வரணும். அப்போ என்ன பண்ணணும்? நம்ம இந்த இடத்துல ஒரு ஒர்க் பண்ணணும். ஓகேவா? எஸ். ஸோ சப்போஸ் இந்த பியிலேருந்து சார்ஜஸ் சிக்கு கொண்டு வந்துட்டு அப்படின்னா நம்ம என்ன பண்ணணும்? இந்த இடத்துல என்ன இருக்கும்? சியில் இருக்கக்கூடிய சார்ஜில் இருக்கக்கூடிய பொட்டன்ஷியல் அதிகமாக இருக்கும். சியில் இந்த சார்ஜோட பொட்டன்ஷியல் அதிகமாக இருக்கும். பாயிண்ட் சியில் சார்ஜோட பொட்டன்ஷியல் அதிகமாக இருக்கும். ஏன் அப்படின்னா பாயிண்ட் சிங்கிறது இந்த பாயிண்ட் ஏல இருக்கக்கூடிய சார்ஜுக்கு பக்கத்திலே இருக்கனால ஸோ இது இன்ஃப்ளூயன்ஸ் அதிகமாக இருக்கும். ஸோ இங்கே என்னவா இருக்கும்? இங்கே பொட்டன்ஷியல் அதிகமாக இருக்கும். ஆமாவா இல்லையா? பொட்டன்ஷியல் கண்டிப்பாக இந்த இடத்துல அதிகமாக இருக்கும். ஸோ இந்த இடத்துல பாயிண்ட் பியில் பொட்டன்ஷியல் 50னா பாயிண்ட் சியில் பொட்டன்ஷியல் 80 இருக்கும். ஃபார் எக்ஸாம்பிள். ஓகேவா? எஸ். ஸோ நோட் திஸ் பாயிண்ட். இப்போ தான் கன்க்ளூஷன் வருது. ஸோ எவ்வளோ ஒர்க் பண்ணியிருக்கோம், எவ்வளோ அமௌண்ட் ஆஃப் நம்ம ஒர்க் பண்ணியிருக்கோம், எனர்ஜி கொடுத்து ஒர்க் பண்ணியிருக்கோம் இந்த சார்ஜை பாயிண்ட் பியிலேருந்து சிக்கு கொண்டு வரத்துக்கு. அந்த ரெண்டு பாயிண்ட் இருக்கக்கூடிய பொட்டன்ஷியல் டிஃப்ரென்ஸ் இருக்குல்ல, அதுதான் எலக்ட்ரிக் பொட்டன்ஷியல் டிஃப்ரென்ஸ். பாயிண்ட் பியிலேருந்து இந்த சார்ஜை பாயிண்ட் சிக்கு கொண்டு வரதுக்கு நம்ம எவ்வளோ ஒர்க் பண்ணியிருக்கிறோம், எவ்வளோ அமௌண்ட் ஆஃப் எனர்ஜி கொடுத்து ஒர்க் பண்ணியிருக்கிறோமோ அதுதான் பொட்டன்ஷியல் டிஃப்ரென்ஸ். ஸோ தி அமௌண்ட் ஆஃப் ஒர்க் இஸ் டன் டு பிரிங் அ யூனிட் ஆஃப் பாசிட்டிவ் சார்ஜ் ஃப்ரம் ஒன் பாயிண்ட் டு another point. Here B is one point, C is one point. That is called potential difference. புரியுதா இல்லையா? வெரி ஈஸி ஒன். பொட்டன்ஷியல் டிஃப்ரென்ஸ். சப்போஸ் இது வந்து ஒரு சார்ஜுக்கு பார்த்துட்டோம். சப்போஸ் ஒரு கூலும் ஆஃப் சார்ஜ், ஒரு கூலுமோ 2 கூலுமோ 3 கூலுமோ அவ்வளோ சார்ஜை ஒரு பாயிண்ட்லேருந்து இன்னொரு பாயிண்ட்டுக்கு எடுத்துகிட்டு வரத்துக்கு நம்ம எவ்வளோ எனர்ஜி கொடுக்கணும், எவ்வளோ ஒர்க் பண்ணணுமோ அதுவும் நம்ம என்ன சொல்கிறோம்? பொட்டன்ஷியல் டிஃப்ரென்ஸ் சொல்கிறோம். ஸோ இது வந்து நம்ம சிங்கிள் பாயிண்ட் வச்சு சொல்லியிருப்போம். சப்போஸ் 1 கூலும்னா என்ன சொல்கிறோம்? அது வந்து குவான்டிட்டி அங்கே அதிகமாக வரும். ஸோ தட் இஸ் ஆல்சோ கால்டு பொட்டன்ஷியல் டிஃப்ரென்ஸ். That is also called potential difference. Very, very easy. Please try to understand the concept. Okay? Yes. That's all. So next என்ன பார்த்துக்கோ, ஸோ தி பொட்டன்ஷியல் டிஃப்ரென்ஸுடைய ஃபார்முலா என்ன அப்படின்னா, பொட்டன்ஷியல் டிஃப்ரென்ஸ் ஃபார்முலா என்ன, ஒர்க் டன் டிவைடட் பை சார்ஜ். ஓகே, ஒர்க் டன் டிவைடட் பை சார்ஜ், தி குவான்டிட்டி ஆஃப் சார்ஜ் மூவ், எவ்வளோ சார்ஜ் மூவ் பண்ணியிருக்கு, இங்கே 1 கூலுமா 2 கூலுமா 3 கூலுமா, எவ்வளோ சார்ஜை மூவ் பண்ணியிருக்கோம், எவ்வளோ ஒர்க் கொடுத்து பண்ணியிருக்கோம். ஸோ ரெண்டுமே நம்ம டிவைட் பண்ணால் நமக்கு என்ன கிடச்சிரும், பொட்டன்ஷியல் டிஃப்ரென்ஸ் நமக்கு கிடச்சிரும். ஸோ பொட்டன்ஷியல் டிஃப்ரென்ஸ் விச் இஸ் ஈக்குவல் டு ஒர்க் டன் டிவைடட் பை சார்ஜ். Okay, work done divided by charge. So whenever work is done, the equal amount of energy is consumed. Well, otherwise we can say that is energy also, no problem, not a problem. Here we can use energy also. Okay, so SI unit of potential difference volt. SI unit of potential difference volt. Volt is denoted by a letter capital V. What is that? Capital V. So after named as the Alessandro Volta, who found that potential difference between two charges, that is the reason why the SI unit of potential difference is volt. What is that? Volt. Is that clear? Yes, that's all. So I'll rub this. You note down this all concept in your classwork note. Okay? Yes. See, the electric potential and potential difference formula same. You don't get confusion. Okay, both formula same. That concept only different. In electric potential, we bring the charge from infinity to that point, any particular point. But in potential difference, we bring the charge from one point to another point, one known point to another point other than infinity. Okay, so both formula is similar. Okay, there is no doubt, isn't it? Yes. So look at here. So potential difference. The potential difference which is equal to what is that? Work done. Work done divided by quantity of charge moved. Am I right? Quantity of charge moved. Isn't it? Yes. So the SI unit of potential difference, what is that? Volt. Already we know. So V. Capital V. So what is the SI unit of work done? That is joule. Am I right? Yes. The SI unit of work done, that is joule. So before that, I'll give some short form of this formula for this point. So potential difference denoted by letter V. Yes. Then work done, W, isn't it? Then charge Q. Charge Q. So V that is equal to capital V. Okay, capital V that is equal to W divided by Q. This is potential difference formula. Okay, potential difference formula. V that is equal to W by T. So V for that is potential difference, W for work done, then Q, quantity of charge moved, that is Q. Is it clear? Yes. Note this point. Next come to, so already we know the potential difference SI unit is, what is that? Potential difference SI unit is volt. So here substitute 1, here substitute 1 V. Okay, which V means what is that? Volt. V means volt. Then what is the SI unit of work done? SI unit of work done, joule. Okay, work, energy, both are same, that is joule. So here joule, that is joule. Am I right or wrong? Yes. Next, what is this charge? What is the SI unit of charge? Because charge is there. What is the SI unit of charge? That is coulomb. So divided by coulomb. Divided by coulomb. Okay, next look at here. Potential difference formula is, potential difference is equal to work done divided by charge, amount of charge moved. So work done, potential difference denoted by letter capital V, that is equal to the work done is denoted by letter W and divided by quantity of charge moved, that is Q. Charge symbol is Q. So V that is equal to W by Q. V that is equal to W by Q. This is a formula for this potential difference. Is it clear? Yes. Now come to SI unit. SI unit wise, the SI unit of potential difference is volt. So V is here, that is equal to work done. So work unit joule. So joule is there and divided by then charge unit coulomb. Charge unit coulomb. Okay, you put 1 in front of the all quantities. So 1 volt, 1 joule, 1 coulomb. 1 volt which is equal to 1 joule divided by 1 coulomb. Okay, look at here, 1 volt that is equal to 1 joule divided by 1 coulomb. Now we are going to enter into very important theme or question. What is that? Define 1 volt. What is that? Define 1 volt. Define 1 volt. You might have seen this You might have seen 1 volt, 3 volt battery, 2 volt battery, a 5 volt battery like that. Then TV capacity is 12 volt, fan capacity is 5 volt like that. Isn't it? Yes. So what is 1 volt, sir? What is 1 volt? 1 volt, which means nothing but, it's very easy. Note this point. See, the 1 joule of work, the 1 joule of work is done to bring 1 coulomb of energy is called 1 volt. Okay, what is that? Note these points. 1 joule of work is done to 1 joule of work is done to bring a 1 coulomb of charge is called 1 volt. 1 coulomb of work, 1 joule of work, 1 joule of work is done to bring 1 coulomb of charge from one point to another point is said to be 1 volt. 1 volt. Okay, look at here. Consider the conductor. It's a conductor. The charge is here. Okay, a positive test charge is here. Look at here. Okay, consider the conductor. So this is the conductor. A charge is there. Test charge is there, placed at point B, point A. What is that? Point A. Point A. Is it clear? Yes. So another charge is here. Another one charge is here. So this charge influence will be here. Okay, will be here and here everywhere, isn't it? Yes. So influence will be there. This is point B. So you consider this is point A and this is point B. No problem. Okay, look at here. Very easy. Consider the conductor. Consider test positive charge placed at point A and another one charge placed at point B. Point B. Is it clear? Yes. Here is consider this not a single point. It's a 1 coulomb. 1 coulomb charge. Here 1 coulomb charge is there. There at point B 1 coulomb charge is there. 1 coulomb charge is there. Okay, look at here. So what is 1 volt? 1 volt means nothing but the potential difference is 1 volt is said to be if 1 joule of work is done to bring 1 coulomb of charge from one point to another point is called 1 volt. It's called 1 volt. Is it clear? Yes. Look at here. I'll rub that. I'll draw clearly. You can get confusion. Consider the conductor. Consider the conductor. Yes. Consider 1 coulomb of charge here. 1 coulomb of charge is there. Okay, at point A. At point A, 1 coulomb of charges are there. What is 1 coulomb? 6.25. 6.25 into 10 to the power of 18 electrons or protons are there. That is 1 coulomb. That is 1 coulomb. Okay, you consider 1 coulomb of charges are there. Where? At point A. At point A. Is it clear? Yes. You are applying energy. You are applying energy on 1 coulomb of charge placed at point A to bring the 1 coulomb of charge from point A to point B here. Point B here. Point B here. Isn't it? Yes. Now come to the concept. If you apply, note this point, very easy. If you apply 1 joule of work or 1 joule of energy, if you apply 1 joule of energy on the 1 coulomb of charge placed at point A to bring from point A to point B, that is called 1 volt. That is called 1 volt. So 1 joule of work is the 1 joule of work is done to bring a 1 coulomb of charges from one point to another point is called 1 volt. Is called 1 volt. Okay, note this point, very easy one. 1 volt which means nothing but 1 joule of work. 1 joule of work is done to bring 1 coulomb of charge from one point to another point is called 1 volt. Okay, so look at here. 1 joule of potential difference means nothing but 1 volt. 1 volt is said to be, I'll write here. 1 volt is said to be if 1 joule of work 1 joule of work is done to bring 1 coulomb of charge from one point to another point. To another point is called 1 volt. Okay, define 1 volt is very, very important 3-mark question. 1 volt is said to be if 1 joule of work is done, if 1 joule of work is done to bring 1 coulomb of charge. What is that? 1 coulomb of charge from one place to another place is called, what is that? 1 volt. 1 volt. Okay, wow, yes, I'll explain Tamil. You look at here because very important concept. Consider inga 1 coulomb charge irukku. Inga point A la 1 coulomb charge irukku. இந்த 1 coulomb charge நான் என்ன பண்ண போறேன், 1 ஜூல் எனர்ஜி அப்ளை பண்ணி, ஓகேவா, எனர்ஜியும் ஒர்க்கும் சேம் தாங்க. 1 ஜூல் எனர்ஜி அப்ளை பண்ணி இந்த 1 கூலும் சார்ஜ் நான் என்ன பண்ணுறேன், பாயிண்ட் ஏலேருந்து பாயிண்ட்டுக்கு பிக்கு கொண்டு வந்தால் அதுதான் 1 வோல்ட்டு. அதுதான் 1 வோல்ட். வெரி ஈஸி ஒன். ஸோ 1 வோல்ட் இஸ் டிஃபைன்ட் ஆஸ், வாட் இஸ் தட்? Potential difference. The potential difference between the two terminals is 1 volt. If 1 joule of work is done to bring a 1 coulomb of charge, either positive charge or negative charge, from one place to another place is called 1 volt. Okay, that is called 1 volt. Very easy. ஓகே, நிறைய இடத்துல பார்த்தலாம், இது 1 வோல்ட் 2 வோல்ட் பேட்டரி 3 வோல்ட் பேட்டரி அப்படின்னா என்ன அர்த்தம் அப்படின்னா, அங்கே பொட்டன்ஷியல் டிஃப்ரென்ஸ் எவ்வளோ இருக்குன்னு அர்த்தம். அங்கே எவ்வளோ பொட்டன்ஷியல் டிஃப்ரென்ஸ் இருக்கா, அங்கே ஒரு ஜூல் அமௌண்ட் ஆஃப் ஒர்க் நடந்து அந்த 1 கூலும் ஆஃப் சார்ஜ் வந்து ஒரு பிளேஸ்லேருந்து இன்னொரு பிளேஸுக்கு போனால் அதுதான் என்ன சொல்கிறோம், 1 வோல்ட்டுன்னு சொல்கிறோம். வெரி ஈஸி தான், ரொம்ப ஈஸி. ஓகே, ஸோ திஸ் இஸ் கால்ட் 1 joule. So sorry, 1 volt. 1 volt which is equal to 1 joule divided by 1 coulomb. This is very, very important formula. Note on your class work. 1 volt which is equal to 1 joule divided by 1 coulomb. Okay, 1 coulomb. It's very easy. Okay, yes. How can we measure the potential difference, sir? How can we measure the potential difference? Yes, we can measure the potential difference across the two terminals of the any material by an instrument, that is voltmeter. That is voltmeter. So voltmeter is an instrument which is used to measure the potential difference between two terminals of the any material or any appliances. Okay, that is voltmeter. The voltmeter symbol will be like this. This is positive terminal and this is negative terminal. This symbol. Voltmeter is an instrument which is used to measure the potential difference across the two terminals. Isn't it? Yes. This voltmeter is always connected in parallel to the where the potential difference to be calculated. Okay, for example, consider the conductor. Look at here. Consider the conductor or any other material. Conductor. Consider the conductor. So this is one end, this is point A, terminal A, this is terminal B. Okay, consider this is conductor. This is conductor. Point A is one terminal of the conductor and point B is another terminal of the conductor. Here at point A there will be different potential and point B there will be different potential, that is called potential difference. Here this voltmeter is always connected parallel to the two terminals of the conductor. Parallel. So look at here. So this voltmeter is parallel to this conductor. This voltmeter is always connected in parallel to the any material. So where the potential difference to be calculated. Okay, to be calculated. Is it clear? Why? Because this voltmeter has high resistance. So if we connect in series wise in the electric circuit, this voltmeter affect the current flow. Suppose if we connect the voltmeter in parallel, what will happen? It is that it takes the current level is negligible. Okay, it means it takes a very less amount of current. Okay, so due to which this voltmeter is always connected parallel to the, so where the potential difference to be calculated, the two terminals. Okay, that's all students, very easy concept. Okay, is there any doubt? No doubt. Okay, I'll explain Tamil. So what is 1 volt? 1 volt na enna? ஒரு கூலும் சார்ஜ் கன்சிடர் பண்ணிக்கோ. ஒரு கூலும் சார்ஜ் மேலே 1 ஜூல் எனர்ஜி ஆக்ட் ஆகி அந்த ஒரு கூலும் சார்ஜ் வந்து ஒரு பிளேஸ்லேருந்து இன்னொரு பிளேஸுக்கு போச்சுன்னா அதுதான் என்னது 1 வோல்ட்டு. வாட் இஸ் தட்? தட் இஸ் 1 வோல்ட். ஜெனரலாக விஷயம் வோல்டேஜ் சொல்லுவோம் இல்லையா, 1 வோல்ட் தட் இஸ். ஓகே, வெரி ஈஸி ஒன். ஸோ இந்த வோல்டேஜை நான் எப்படி சார் மெஷர் பண்ணுறது அப்படின்னா, விச் மீன்ஸ் த பொட்டன்ஷியல் டிஃபரன்ஸ் எப்படி மெஷர் பண்ணுறது அப்படின்னா, ஒரு இன்ஸ்ட்ருமெண்ட் நமக்கு வேணும். அந்த இன்ஸ்ட்ருமெண்ட் தான் வோல்ட் மீட்டர். தட் இன்ஸ்ட்ருமெண்ட் நேம் இஸ் வோல்ட் மீட்டர். அந்த வோல்ட் மீட்டர் நான் எப்பவுமே எப்படி கனெக்ட் பண்ணுமா, ஒரு சர்க்கியூட்டில் அந்த அந்த அப்ளையன்சிஸ், ஓகே, அந்த கண்டக்டருடைய பேரலாக தான் கனெக்ட் பண்ணுவோம். ஏன் அப்படின்னா வோல்ட் மீட்டருக்கு ரெசிஸ்டன்ஸ் ஹையாக இருக்கும். ஓகே, ரெசிஸ்டன்ஸ்னால் பின்னாடி என்னென்னு பார்ப்போம். ரெசிஸ்டன்ஸ் ஹையாக இருக்கும். நம்ம சீரியஸாக கனெக்ட் பண்ணோம் அப்படின்னா அந்த சர்க்கியூட்டில் ஃப்ளோ ஆகக்கூடிய கரண்ட்டை அதை அஃபெக்ட் பண்ணிடும். அதனால் நம்ம என்ன பண்ணுவோம், பேரலாக கனெக்ட் பண்ணுறோம். ஸோ பேரலாக கனெக்ட் பண்ணும்போது என்ன ஆகும், இந்த வோல்ட் மீட்டரோட ரெசிஸ்டன்ஸ் வந்து அந்த கரண்ட்டை அஃபெக்ட் பண்ணாது. தட்ஸ் ஆல். ஓகேவா? எஸ், வெரி ஈஸி ஒன், very easy. That's all about this. That's all about this potential difference, isn't it? It's a very easy concept. Please try to understand my concept, what I'm telling here.